Okay, welcome to lesson 2.1. This is the second chapter of our year, and this is the beginning of an area called powers, which works its way into radicals in grade 10-C. So you have to learn these power laws, and we're going to be going through them from the basics all the way through. And it's going to require a little bit of memorization. So let's start with the beginning of what a power is. So if you've got an actual square here, it says, what is the area of this square? Well, since it's a square and all four sides are equal, this is a 1 by 1 unit square, which means that this is 1 unit squared. Okay, so the area there is 1, or 1 square unit. Now, how to use the side lengths of this square to find its area? You multiply the length by the width, or in this case, it'll be side by side. Okay. Now, anything that is multiplied by itself is referred to as being squared, so it is really the side squared. So let's take a look at this little table right here. In this table, I've got a 1 by 1, 2 by 2, 3 by 3, and a 4 by 4 squares. All right. The edge length of the first one we know is a 1. As a product of its edges, it's 1 by 1, and that gives you an area of 1, and I'm not putting the units in. So pause the recording, and I'd like you to fill the rest of this chart out. Okay, so we now have a 2 unit side, so that's 2 by 2. That means that's a 4. This is a 3 unit side, 3 by 3. That gives us 9. This is a 4 unit side, which is 4 by 4, and that gives us 16. And these are our first 3 perfect squares that you should remember from before. Moving on to page 2. My alignment is a little bit out. Okay. Powers are a short form for writing down numbers that have repeated multiplication. For example, above a square, in the example we just did, it had an area of 1 square unit. It's made up by multiplying itself 1 by 1. So it can be written as 1 squared, and this means 1 by 1. It's spoken, if you want to say this, as 1 to the power 2, or 1 to the 2, or 1 squared. So why do you think 1 squared is a way of expressing 1 by 1? Well, 1 by 1 creates a square. It is a square. So that's where the word square comes from. So when you say 1 squared, it means take a 1 unit edge length and apply it to a square and find the area. So some repeated powers here to help you out. 1 times 1 would be 1 to the power of 2. 2 by 2 would be 2 to the power of 2. 3 to the power of 2, 4 to the power of 2, and 5 to the power of 2. It's important that you know that 1 times 1 is 1 squared and that 1 are all the same. This is just a way of writing same thing in different format. So, what are the powers of a square? You're going to be asked to manipulate these things, so you have to know what each of the names is. The 2 here is referred to as the exponent. The 3 is called the base, and the whole thing is called a power. So, what do these actually mean? Well, the base is the number. Well, its base is it's the side length. We want to think about it that way in a square, but it's more than that. It's the number that you multiply by itself. So it's the number multiplied by itself. In a square, it's the side length. The exponent is the number of times you multiply the base by itself. And finally, the power is a base with an applied exponent. So it's the whole thing. For example, 6 with a floating 2 means 6 multiplied by itself 2 times. and that would give you a product of 36, or a value of 36. So see if you can fill out the following charts. I'd like you to pause the recording and fill out that chart for me. All right, so the base in 2 to the 2 is 2. The exponent is 2. Written as a product is 2 by 2, and the value is 4. Now, if you couldn't get the first one, you can pause the recording and finish off the rest of them. Okay, so here we have 3 as the base. 2 is still the exponent, so that's 3 by 3, which is 9. And then, of course, 7 is the base. 2 is the exponent. 7 by 7 gives us 49. 12 is the base. 2 is the exponent. 12 by 12 gives us 144. So the question is, can any number be written as a power? And the answer to that is yes. Sometimes when you're given a number, you're not told that it's actually a power because the number is assumed to be there. For example, if you ever see a number like simply 3, 3 actually has a value of an exponent. There is an exponent there. But every whole number, it has an exponent of 1. So rather than writing a 1 floating on every number we ever do, we just don't do it, but we know it's there. So 4 has an exponent. It's a 1. 6 has an exponent. It's a 1. 104 has an exponent. It's a 1. But we don't put it there. It's kind of like that we know that every number has a denominator of 1 also. So let's look at 3 dimensions now that we have the square stuff all figured out. Here is a cube. So how can the edge length of this cube be used to calculate the volume? Well, if you remember, the volume is equal to length times width times height. But in a cube, they're all exactly the same. So for this one, it's actually got a 3. So your volume is 3 times 3 times 3. So when you write this, I guess I've kind of put this in the wrong spot. So what is the volume? Well, 3 times 3 is 9, and 9 times 3 is 27, and that's cubic inches, or cubic centimeters, because we're using a centimeter cube. All right. So how could you check if you're correct? Well, you could take the cube apart and count the pieces. Disassemble and count. But that doesn't necessarily the easiest way to do it. How is this different from the squared example? Well, we have in a square, you only have 2 dimensions, length and width. In a cube, we have length and width, which is our base, and we also have a height. So it has 1 more dimension. And that is height. So write the volume of this cube above as a power. It has an edge length of 3, but there are 3 dimensions, so it is 3 to the power of 3. Let's take a look at the next example. Here's a different cube. Let's see if you can go through and fill out all the information about this cube. I want you to write the volume of the cube as a product of its edge lengths, the volume itself, tell me how it's different from the other cube, and then I want you to write the cube as a power. So pause the recording and fill out these 4 questions. All right, so first off, product of its edge lengths. You can see that it's got 4 squares there, 4 squares there, and 4 squares there. So it is a 4 by 4 by 4 cube. So this is 4 by 4 by 4. What is the volume? Well, you have to calculate what 4 times 4 times 4 is, and that is 64. And that's units cubed, or cubic units. And how is this different from the other cube? Well, the other cube had an edge length of 3. And this one is 4. So what is this one going to do as a power? Well, now the base has changed. It's no longer a 3. The base is now 4, but we still have length, width, and height, which is 3 dimensions. So when a power has an exponent of 3, why do you think we call them cubes? Well, That goes down to 3 dimensions make a cube. So that's why we call them cubic centimeters or cube. Okay, so it has to do with exponent of 3 is 3 dimensions. Because of that, it's called a cube. Ooh, my writing's getting better, getting worse. It's called a cube. All right, now there is no 4th dimension version, so there's no shortcut for its words. So let's take a look at the next table. I'd like you to take a look at it. Oh, I did it again. I have to change my alignment. So here's a table that's got cubes rather than squares this time. I'd like to go through, and I'll do the first one for you, and then you can fill out the rest of them. The edge length of the first one has an edge length of 1. The volume, as a product of its edges, is 1 times 1 times 1, length, width, height. When you calculate it all out, you get 1. So, pause the recording and finish off this table. Okay, so second one has an edge length of 2. So that means it's 2 by 2 by 2. And 2 times 2 is 4. Multiplied by 2 again gives me 8. And this one has an edge length of 3. So that is 3 by 3 by 3. And that gives us a volume of 27. This one is 4. So that has got a base length of 4, or an edge length of 4. And it is 4 by 4 by 4. So that's 4 by 4 is 16. 16 times 4 is 64. Okay. And the last one is 5. 1, 2, 3, 4, 5 edge length. And 5 by 5 by 5 is 125. So there's your first 5 cubes. So far, so you've been introduced to squares and to cubes. Obviously, there are more powers with exponents greater than 2 or 3, but there's no special names for them. So what I'd like you to do is, using your calculator, I want you to see if you can fill out these rows. So for 3, the power is 3 to the power of 1. The exponent says there's a single 3 there. The value, when you calculate it, is a 3. The next one is 3 times 3. So as a power, there are 2 3's there, so the base is 3, and there are 2 of them. And of course, 3 times 3 is 9. I'd like you to finish off the rest of these, please. All right, so 3 to the 3 is equal to 27. 3 to the 4 is equal to 81. 3 to the 5, that's equal to 243. 3 to the 6 is equal to 729. And the last one, 3 to the 7, is equal to 2,187. And of course, you use your calculator to do that. Okay, turning the page, let's take a look at some different things here when we mix them all up. So we've got a 7 to the 1, 2 to the 4, 5 to the 4. So these are all different now. So what I'd like you to do is to go through and fill out the base, the exponent, and the product, and then calculate the final value. Okay? Do that, please, right now while we, for a couple of seconds, pause the recording and do it. All right, so here we go. The base is 7, the exponent is 1. The product would be 7 multiplied by itself 1 times, or just 7, and the value when you're done is 7. 2 to the 4 has a base of 2, and exponent says 4, so multiply the 2 by itself 4 times. And 2 times 2 is 4, times 2 is 8, times 2 is 16. 5 to the 4, the base is 5, the exponent is 4, so multiply the 5 by itself 4 times, and that gives you 625. And 6 to the 5, the numbers are getting bigger now, but the base is 6, the exponent is 5, which means multiply the 6 by itself 5 times. So 6 times 6 times 6 times 6 times 6. And when you do that on your calculator, you get 7,776. Moving up to the 8 to the 3 now. Well, the base is 8, The exponent is 3. That means multiply the 8 by itself 3 times. And 8 times 8 is 64, and 64 times 8 is 512. Getting into some bigger numbers here. 10 to the 6th, the base is 10, the exponent is 6, which means multiply 10 by itself 6 times. So 10, 2, 3, 4, 5, 6. And that would be a 1 followed by 6 zeros. So that is a quick way of writing a million. And the last one, the big number, 12 is the base, 8 is the exponent. So you've got to multiply 12 by itself 8 times. So you have to write down 12 eighths and multiply them. So there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 12 times itself 8 times, and that gives you a big number. It is 429981696. So there you go. Okay, so simple questions that I want you to understand that will lead to your better understanding of what we're doing. How are 2 to the 3 and 3 to the 2 same? Well, you can tell that they're using the same numbers. They use both 2 and 3. How are they different? Their bases and exponents are different. Okay? So if you take a look at going down just to help you out with, are their values the same? 2 to the 3 means 2 times 2 times 2. So the base is 2, whereas 3 to the 2 is 3 by 3. The base here is a 3. So the bases are different. The 3 on the first one means multiply the 2 by itself 3 times, and the 2 exponent on the second one means multiply the base of 3 by itself twice. So when you do the calculations, this one actually comes out to be 8, and this one comes out to be 9. So you can see that they're very different. Even though they're both using a 2 and 3, they are different values. Now, if I wanted to draw this and model it, I mean, 2 to the 3 would be a cube because it's 3 dimensions. So it would be looking something like this. Okay, 2 by 2 by 2. Now 3 squared would be 2 dimensions, so it's just length and width. So we've got a 3 by 3 grid. And this one here being 2 by 2 by 2. So you can see they actually draw, or they actually represent something completely different. So far we have used positives. So now let's talk about negatives. The negatives are very, very tricky. The most important thing for you to understand when dealing with negatives is when does the negative sign get included and when does it not get included. Well, a set of brackets around a negative sign means that the base is a negative number. If there are no brackets, that means the base is not a negative number, that it's just a subtracted positive number. And you have to understand that because they give different values at different times. So let's look at negative 2 to the 1 and negative 2 to the 2. All right, well, let's go back up here. Why do you think the brackets are included around negative 2? Well, brackets force the base to be negative 2. So when you apply the power of a 3, it becomes negative 2 times negative 2 times negative 2. If you don't include it, it means subtract 2 to the 3 from something. So let's look at the 2. Are these the same things, negative 2 to the 2 and negative 2 bracketed 2? The answer is no, they're not. Okay? In fact, if you take a look at negative 2 to the 2, the base is a 2. All right? And a negative 2 inside brackets, the base is a negative 2. All right? So let's take a look at 5 to the 3. What is the base? Well, if you take a look, it's a positive 5. Now take a look at the second one. what is the base? Now here's where it gets kind of difficult or a little bit tricky. Because there's no brackets, that means that the base here is also a 5. This here negative sign, and you've heard me tell you this before, a negative and a subtraction are the same thing. So what this is saying is take away 5 to the 3. So 5 times 5 times 5 would be equal to 125. All right, so this is 5 times 5 times 5, whereas the other one is a negative or take away 5 times 5 times 5. So this one is negative 125, and you can see that there's a very big difference between the two of them. Let's take a look at some other examples and see if we can get a clear understanding. So if you take a look at the first one, inside the brackets is a positive 5. So brackets include the sign of what is here. So that is a 5, or a positive 5. If you take a look at this next one, inside the bracket is a negative 5. That means the base is a negative 5. Now, next one kind of trickier, but if you look at the brackets, inside the brackets, when you're doing 5 to the 3, that 5 is a positive inside those brackets. So the base is a 5. So this is actually saying take away or subtract the power 5 to the 3. Okay? And taking a look at the next one, if you take a look at this, remember order of operations, you do brackets and exponents before you do a subtraction, so the base here is also a positive 5. These are the trickiest things you have to keep track of. When is there a base and when is there not a base, being a negative? So let's see if you can put this into play and get the proper values. This is the same chart as we just did. So if you just fill in the numbers on the back here, you're going to have a 7, and you're going to have a 16, a 625, a 776, a 512, a 1 million, and then of course you're going to have a 429981690. Those would be the numbers when you take and you square the numbers. Now the only thing that's going to change these is that some will be positive and some will not. So let's take a look at the first one. If you take a look at negative 7 to the power of 1, there is no brackets forcing the negative to stay with the 7. So this is like subtract 7 to the 1. So the base here is a 7. The exponent is a 1. What this means is take away a 7 multiplied by itself once. So this answer is negative 7. Negative 2 to the 4. Again, no brackets forcing the negative to stay with the 2. So this is like subtract a power 2 to the 4. So the base is a 2. The exponent is a 4. So you have a subtract a 2 by 2 by 2 by 2, which means that your final answer is going to be negative. Now, taking a look at the negative 5. This time it's inside brackets. That means the base is negative 5. And the exponent is 4. Now, because the base is negative 5, the 4 means multiply the base, negative 5, by itself 4 times. So this becomes negative 5 times negative 5 times negative 5 times negative 5. Now, a negative times a negative is a positive. A positive answer times a negative is a negative. And a negative answer times a negative means that this is overall a positive number. Now, taking a look at the next one. This one has got a 6 to the 5 inside brackets, but there's no negative inside the brackets stuck to the 6. So this is like subtract the exponent 6 to the 5. So the base is 6 and the power is 5. What this means is take away 6 to the 5. Now 6 to the 5 is 6 multiplied by itself 5 times. Now 6 times 6 times 6 times 6 is 776. And of course it means take that away. So that's negative 776. All right, our next one is a negative 8 with a power, brackets and the 3 outside. This has still got a positive 8 base because the negative is not inside the brackets. So that's positive 8. Our exponent is 3. So we want to take away 8 multiplied by itself 3 times. All right, so whatever 8 times 8 times 8 is, we're going to remove it, subtract it, so that's negative 512. All right, now this one gets even trickier. Now we want to take away a negative, And inside the brackets is a negative 10 to the 6. But remember, there's no brackets forcing the negative and the 10 together here. So this is like the one we just had a minute ago where we have the negative right here. It's not attached to the 10. Right? It's just subtract. So we have a subtract here. Let's deal with this first. A subtract 10 to the 6. The base is 10 and the exponent is 6. So we have 10 times 10 times 10. There's 6 of them. Now, whatever this is, we're going to make it negative because that's what this negative does right here, the inside one. But once we've calculated all that stuff, we're going to remove it. So that means that you calculate 10 by 10 by 10 6 times. That's a million. So originally, inside the brackets, the million is negative. But we are also going to take and subtract that negative. Well, two negatives make a positive. So this one is a positive 1 million. Now, negative 12 to the 8. You take a look inside here. These brackets say just keep everything together. Well, the negative is not inside brackets with a 12, so that means that your base is going to be a positive, and your exponent is going to be an 8. So you're going to multiply 12 by itself 8 times. 2, 3, 4, 5, 6, 7, 8. Now, whatever you get for 12 to the 8, you're going to subtract it, so that's going to be a negative. So that means that our 429 million is going to be a negative answer. All right, so that concludes lesson 2.1. Try the assignment. If you have any questions, go back and rewatch the video. And if you have any problems with that, you can come in and see me.